Good afternoon, and welcome to the Diesel Technology Forum's webinar, Keeping the Lights On and Critical Services Functioning, Technical Options and Policy Solutions for Maintaining Continuous Electrical Power During Loss of Grid Power. During the presentations, all participants will be in a listen-only mode. As a reminder, this event is being recorded. The recorded webinar and the presentations will be available on the Diesel Technology Forum website shortly after the live presentation. To ask a question at any time during the event, submit a question via the Q&A box. We encourage you to ask questions at any time during your presentation. Your questions will not be viewable by other attendees and will be addressed during the Q&A at the end of the session. I would now like to turn the call over to your moderator for today, the Diesel Technology Forum's Executive Director, Alan Schaefer.
Thank you very much, Kristen, and good afternoon, everyone. Thank you for spending some time with us here. A quick word about the Diesel Technology Forum here. For those of you familiar with us, we are a not-for-profit educational organization based in Frederick, Maryland. That's just outside of Washington, D.C. And our work is focused on education, outreach, research, and collaboration on all things concerning diesel engines and equipment. And that includes power generation, as you'll find out here today. The members of the Diesel Technology Forum are the leaders in clean diesel technology, and we thank them for their support of the work that we do. And you're going to hear from some of them here today on this call. So with that, I'm delighted to serve as your moderator today and also to offer a few insights about some of the basics on the technology choices that are available, but also want to welcome Jason Kitchell from Caterpillar, Ezra Finken, our Director of Policy here at the Diesel Technology Forum, and Mike Jones with the Maryland Energy Administration. And you'll be hearing from everyone here momentarily. Our program today is going to cover several areas. First of all, we're going to discuss some of the electricity and grid supply outage situations and the frequency of those kinds of events. We're going to provide you with a basic introduction to backup power choices, what fuel and technology choices are available out there and which are suited better or worse for some applications. We'll also discuss those technologies offered in emergency standby applications. And we're going to conclude with a look at some policy initiatives that have encouraged the implementation of these backup power capabilities. And finally, hear about a very innovative program right here in our home state in Maryland that has helped to encourage and incentivize the installation of backup power systems and quick connect systems. So with that, we will begin our discussion today. And we are going to have a future webinar that will discuss issues around demand response, which is related to electrical power generation. But today's webinar will be focused exclusively on on emergency backup power. Well, as everyone knows, our world is dependent on a continuous supply of high-quality electricity. It's vital to everything that we do, to commerce, communications, and most importantly to public health and safety. Whether that's cellular communications, our nation's banking system, the internet, or something as simple as air traffic control and getting gas at your local gas station, all of these things rely on continuous electrical power. But the result is generally the same, that when grid power goes out, these systems go down and there's some impacts, particularly from severe weather, that have a negative result on the grid reliability and therefore everyone's ability to have electrical power in their homes and businesses. And that's what we're going to address here today. The causes of the large blackouts in the U.S. have been fairly widely studied and captured here on this slide. And you can see that it's not the big high-profile events that are the cause of concern, the Superstorm, Sandys, and those once-in-a-lifetime events, but rather the majority of outages come simply from equipment failure, also from operator error, and the kind of regular weather events that we're likely to experience every day, such as wind and rain and lightning, and some of the folks in the Southwest are experiencing that in significant quantities here today. But these are all different causes of electrical blackouts in the U.S. And the nation's electrical grid has been identified as being vulnerable to extended outages and has been reported on most recently in the Wall Street Journal back on March 12th, where Some reporters identified some federal memos that highlighted the vulnerability of the electrical grid and its concern for our nation's overall stability. The frequency and impact of the electrical outages is growing. Going back to 2008, there were just over 2,000 outages a year. And in 2013, the last full year of data availability, that number has jumped to over 3,200 outages per year. And that's a 58% increase over a 5-year period. No matter the cause of the blackout, the consequences are generally the same. Folks cannot do the things that they need to get done, whether that be working or their home activities. And there is the matter of public health and safety threats, which is a major focus of our discussion here today. On the economic side, when the power goes out, not only is it inconvenience, but it's also an impact on our economy and to the businesses directly. According to some recent research from Lawrence Berkeley Lab and Symantec Corporation, the economic impacts of electrical power loss in the U.S. total about $80 billion annually. And you can see that the bulk of that, 3/4, come from the commercial sector. And a smaller percentage come from residential, and finally a smaller percentage from the industrial sector. This study also identified that the median loss per day to small businesses for power being out was on the order of $12,500. Of course, for many small businesses, that's a significant amount and could threaten their viability if it goes on to an extended period. Unfortunately, we do have some experience firsthand in the U.S. with some ongoing and major outages. Many of you will remember the outage in August of 2003, just over, I guess, 11 years ago now. But that impacted more than 50 million people in 8 states and Canada. It took 30 hours to restore, and the estimated cost to the economy was about $7 to $10 billion. Some specific examples of blackouts involve everything from manufacturing plants, nation's chemical processing facilities, simple access to drugstores, our air traffic control system and transportation networks, and finally the New York City Comptroller estimated that in that city alone losses exceeded $1 billion, including $800 million for gross city product. So the major blackouts that last 30 hours, like the one in the Northeast, can have quite substantial economic impacts. Another event that we're all too familiar with is the most recent Superstorm Sandy, which impacted the Northeast of the United States, impacting a large number of states and a large number of people in this densely populated area. And over 8 million customers were without power at the peak of the outage after this superstorm came through the region. We did want to highlight briefly the role that diesel power played in Superstorm Sandy's recovery and folks responding to that situation. And that was included things like getting the internet back up, and all of the data and financial centers, which are heavily concentrated in New York, rely on diesel generators to keep those systems functioning. And we also saw that the diesel generators really demanded more fuel to be available, and EPA responded favorably, providing some waivers to get that fuel where it's needed in a timely way. And this is an indication of the role that diesel generators play in protecting our critical systems during these times of outages. We're going to focus more on that during today's session. But we are going to discuss what are the broad range of technology options for backup electrical power. And there are many. There are stored energy systems, and this can include solar panels with battery storage systems. Flywheel energy can also be a source of storage and is often combined with other supply sources in commercial applications. Uninterruptible power supplies, UPS systems. Many small businesses may have these with a battery pack hooked to their local network server to keep the thing running for a few hours after the grid power may go out. More sophisticated systems involve the use of turbines for combined heat and power systems in places like hospitals and other business facilities that have a need for continuous heat and electrical power. And finally, one of the newest areas is fuel cell systems. But today's discussion, we are going to focus pretty exclusively on generators. And when we say the word generator, what do we mean? Really, this is a combination of three things. It is the internal combustion engine that burns the fuel to create mechanical energy, an electrical power generator that turns that mechanical energy into electrical energy, and then finally the electrical controls and switchgear that turn that into usable power in a building or situation for plugging in various appliances. And we're going to look at the four fuels that are the primary options for generators in just a moment here. And also we'll take a peek at some of these other sources and some of the advantages and disadvantages of each. And I think one thing to stress at the outset here is that there are many solutions, and there's many solutions. Some are better than others for certain applications, and it all depends on what the needs are for each application. So there are situations where natural gas, propane, and even gasoline make great sense, and in many cases you'll find that the diesel system may be superior to some of those fuels in many settings. And we're going to talk through that a little bit right now. In a very simplistic sense, electrical generators come in many shapes and sizes. They can be purchased at your local home improvement store in their smallest form, such as those on the left. Some residential communities and new building construction now includes a residential home size backup generator, such as at the bottom left of the screen there. These are typically gasoline powered if they're portable, and if they're stationary, they're typically powered by natural gas or propane, depending on the fuel supply at a particular home. Another category of generators are those that might be used by contractors or for light industrial use. And these are typically portable, owing to the need to serve different job sites at different times, and they're often for short-term use. And these are powered most often by diesel and sometimes gasoline for some applications, particularly in smaller residential construction and other uses. And finally, there's the business applications for emergency backup generators, and these can be either mobile or stationary, and the fuels that can be used range from diesel to natural gas and propane. I want to emphasize that there are a range of fuels and applications out there, and the industry has specific terminology that we look at for each of these generators and their descriptions. And what purpose that they serve helps to understand also how they are regulated. So this table here gives you a simple breakdown of the different kinds of generator applications where you might find these internal combustion engine generators at work. Stationary emergency, non-road mobile, which is also an emergency application. And then there are several other applications which will not be discussed as part of today's call. Those include peaking use, demand response, the combined heat and power, and those situations where generators provide continuous or prime power for specific use. A great example of that is an island that has no connection to an electrical grid. It has its own generator that runs as a prime power source. But for today's focus, we're going to look at specifically emergency backups, and those can be either mobile or stationary. First, we're going to take a little bit of a look at some of the alternatives to emergency backup generators. And first of all is batteries. And everyone is familiar with the battery that helps start cars in the morning. Battery backup systems used for emergency power situations typically involve large banks of batteries, multiple units all strung together. That can either be lead acid or lithium and some other different supply sources of energy within the batteries. But they have various characteristics. They're scalable. You can put multiple ones together. They're fairly easy to replace and maintain in the right kind of setting. And they do provide a way to cover short power outages. They do have some disadvantages, however, and most notably is that once that electrical supply in the batteries is depleted, there's no way to replenish it. And if the power is still out at that point, you're in a non-power situation. For generators, the characteristics that we look at to evaluate those systems, and first of all, is rapid response. And these are situations where a quick start is needed. And a great example of that would be a hospital setting where the power may go out from the grid, and emergency systems in intensive care units, operating rooms, other main electrical circuits in a hospital need immediate power. These are situations where you need a 10-second response time as required by health and safety codes, and both diesel and natural gas can provide that. Gasoline also can be used in some of those settings. There is a portable market for generators. Gasoline ones, as we've mentioned, are typically the technology of choice when you're talking about things that one or two people can move around easily. They do rely on folks connecting things and starting engines up directly. The diesels that are provided are typically larger power owing to the higher energy density of the fuel, and these are the most common choice for rentals for business and industrial use. Finally, there's the stationary market, and these are engines that are installed inside buildings and facilities, and there's a range of power available for these units, anywhere from 10 kilowatts on up through 1.8 megawatts. The diesel can provide anywhere up to 3,000 kilowatts of output for those units. Taking a look at some of the considerations of the different fuels, gasoline is readily available. It is independent of the utility, so you can get gasoline pretty much anywhere and store it in reasonable quantities at your business or at your home. It does start fairly well in cold conditions, and it's a fairly reliable engine technology, and of course is quite portable. The disadvantages of gasoline as a fuel for backup generators is its low energy density and output limitations. Gasoline engines can generate a lot of heat, and therefore their size limited, and you won't find ones that are very large typically. They generally have lower durability, and that's useful life compared to a diesel. There are considerations for the quality of gasoline that's available, and anyone that's tried to start up their lawnmower after a season of not treating the fuel properly and having trouble getting an engine going will be familiar with that. So there are issues relative to fuel quality and keeping the not only the storage system but also the delivery system free of deposits and from gumming up during periods of downtime. The cost of gasoline is variable. We have seen gasoline prices moderate recently, but those can be upwards of $4 a gallon in some parts of the country. There are some safety issues relative to gasoline, obviously, in its ignitability. It is quite a flammable product, and spilling it or having vapors running around are definitely not good things. And finally, there are some disadvantages of gasoline use relative to the emissions that are produced. And we hear all too unfortunately during times of power outages where homeowners and others have installed generators, gasoline generators too close to their homes, and carbon monoxide fumes have entered into a home and rendered folks unconscious, and some have lost their lives that way. This is a major problem and consideration for the use of gasoline generators. On the diesel side, diesels do have the advantage of the highest BTU content for the volume of fuel, so the power density is at the top of the curve. It is a combustible fuel, but not as volatile as gasoline and other flammable liquids. Like gasoline, you're not dependent on the utility grid. And diesel can also be important for earthquake-prone areas where pipeline service of natural gas and other gaseous fuels may be interrupted, either by the breakage of the pipeline or as a safety measure by the operator of the utility shutting down natural gas supplies due to fire risk. The other advantages of diesel engines are the start time. They have a very quick response time, as we've noted. And of course, the engines can run for quite a good time. They're very durable engines, very reliable, and they're generally portable. The disadvantages of the diesel, there are limitations about the shelf life of diesel fuel, and some maintenance of that fuel system is required on an ongoing basis for backup purposes. The cost of diesel fuel, like gasoline, is variable and can be higher than other fuels at some times. And there are also some permitting requirements relative to diesel engines that may come into play, particularly those that may be used not only for backup emergency power, but potentially other uses. So we're not going to get into the details of that today, but that is one of the considerations. For gaseous fuels, there are advantages here. Obviously, it's a steady national fuel supply that's available of natural gas and propane. Historically, these have had generally lower fuel costs than diesel, and because it's served by a pipeline, there are no fuel storage costs, so no tanks to maintain and the associated cost and installation there. The disadvantages of gaseous fuels, one is that they have a lower power density than diesel, and that typically requires a larger engine to produce the same amount of electrical output. They typically have lower durability compared to gasoline and diesel engines. There are some seasonal supply shortages and cold weather start concerns for propane. I think over the last year there was a major issue in the Midwest about the supply of propane, and that's just one recent example of a supply concern. There is a reliance on the utility to supply that gas, and if that utility shuts the gas off, as we've mentioned, the generator will not work. And also for propane, there are limitations on the storage for that based on codes and health and safety codes and zoning requirements that may limit the size of the propane vessel for storage of the fuel. So as you can see from this brief overview, each fuel has its positives and negatives, its advantages and disadvantages, and some fuels will work great for some applications and others will work for other applications. So at this point, we'll move into our next speaker, and let me let's see. We've jumped ahead there a little bit. My apologies there. We're going to bring up our next speaker here, and I believe that is Jason Kitchell from Caterpillar.
Thanks. I could ask you to pass the ball control up to me. Perfect. Well, thanks, Alan. I appreciate that description of the playing field and laying out all the different aspects of power generation that can be considered. It's a lot. As you mentioned, my name is Jason Kitchell, and I work with a group called Cat Rental Power, the division of Caterpillar. So specifically what we do is we develop our distributors and companies around North and South America who have generator rental businesses, and we rent power, temperature control, and compressed air. And a big portion of our business can come during natural disasters or other unplanned outages. Certainly there's a lot of other applications, but I've been in this position for 10 years now, and I've been able to support multiple situations, beginning with Katrina. I also had the opportunity to go to Japan after the tsunami took out their nuclear facility and helped restore some power there. And I also assisted in the moving of generators up to the Northeast for Superstorm Sandy. So I'm going to be drawing on some of those experiences to hopefully help spur some ideas or some thoughts about how trying to work through an environment which is unfamiliar, what can we do now in order to make it more workable should we ever find ourselves in that situation? And so that's what I hope to walk through with you today. And please, if there's any questions, write them down, submit them, and we can talk about those at the end. I'd be happy to have that discussion with you. The first thing we need to kind of lay out is that at least from the distributor perspective of temporary or mobile power generators, it's amazing what an emergency for one person is relative to another person. And in situations where we have loss of grid power, the number of calls that'll come in, and someone calls in completely frantic and has a horrible emergency going on, and what's wrong, you know? And we find out, well, their television went out and their two favorite teams were playing a football game. And that's really not exactly who we're set up to serve. We are, in most generator rental companies, are set up to serve municipalities, utilities, businesses, or in some cases, utility grids. So I encourage you guys to think about, what does your application look like? There on the left, you'll see a small 20 kW. That could be used to back up lights and computing power at a warehouse. A lot of times we'll see insurance companies try to process claims, and they can't because they don't have power. So they need to get up and running so that they can start helping other people get going. Maybe it's a industrial facility similar to what's in the middle. Maybe it's a water treatment plant or a pumping station. There's a lot of different applications like that that are going to need multiple generators parallel together, but not a huge operation. Or maybe you're responsible for your city's utility, and there on the right you can see an application of hundreds of megawatts paralleled together in order to support a city during a prolonged period of outage. Maybe it's due to an earthquake. Maybe it's due to maybe your city draws a lot of its power from hydro sources, which a drought could affect. There's a lot of different reasons that these come into play. I'm going to do my best to speak to the considerations in each of these applications, but we don't have time to obviously go into everyone's. But the first thing that is important when considering your own application is, how much power do you need? Which one does it look like? And what voltage are you looking for? Most manufacture smaller equipment, and I'm talking about 800 kW and below, will have switchable voltage between 480 volts and 220. The smaller size will have the 120 or 208 volt available. Above 800 kW, it's going to be 480 volt standard, and then a lot of times you'll have a transformer involved in order to step that up. Now I want to take a little bit of time to go through these 4 areas. And as we do this, I really want to encourage you to think about your plants, the people you work with, and how you would respond in any given situation. Because it's easy to think about your day-to-day responsibilities, and you say, okay, if power went off, I would ask this guy to call that person, and they would get everything here up and running. That seems pretty easy. But time and time again, as we've gone through these experiences, what we've found is that because natural disasters or other causes for outage typically do not strike with laser precision, is that nothing functions normally. And so this guy who you would typically ask and have responsibility for powering of the facility, his family is without a home or shelter, and he's not coming to work today. And so now you have to ask somebody who backs him up to call somebody. And quite honestly, the situation could quite feasibly be the same on the other end of the phone, where the typical expert consultative sales rep who's familiar with your facility and your application, he's not there. He's taking care of his own issues, and so his backup is able to release equipment and do everything they can to help you, but they may not have the expert level that you need. And so in that situation, what can we do? How can we have all of these things thought through in order to make that transaction as simple and straightforward as possible? So the first thing we need to do is we need to look at the location. When we went down to Katrina, it was amazing for a city that was planned at sea level, or in some cases below sea level, how many people actually had their generator rooms and electrical distribution and circuitry in the basement. And so in a serious flood environment, a lot of those rooms were completely destroyed and rendered useless. And so we had to work around that in order to reroute the circuitry and get these facilities back up and running. So I encourage you, if that's a situation and you believe that you could ever be prone to any sort of flood event, that's a first consideration that you need to make for your permanent standby generator. The next thing you want to do is you want to walk around your facility and look at where would I put a temporary generator if we were called upon. Things you want to look for are areas that are going to be easily accessible from the road and in relative proximity to your power generation main circuit breaker. You will also want to make sure that this area is relatively stable footing and it's not in an area that water would naturally flow to if it was a flood type event. You also want to do a quick scan to see if there are any trees or any other sort of hazards that could become a hindrance to getting to that location in the event of some sort of outage. Next thing we want to talk about, which Alan touched on a bit earlier, is your fuel requirements. And most emergency standby generators, at least the mobile ones that you would get for a temporary period, are going to come standard with a 24-hour fuel tank. And that's typically measured at 24 hours of running at 75% of their capacity load. So depending on how much power you're actually drawing off of that piece of equipment, there's actually an ongoing logistical consideration to be made to refuel that genset. Most temporary generator rental providers will provide refueling service as well, but you'll want to understand, is this something we're going to have to let somebody in through a gate once a day, or is it, once a week? And those are the types of things you want to have in mind when you are setting up your temporary system. As far as accessory requirements go, this is something that often gets overlooked. Now, I work at Caterpillar, and most people are familiar with Caterpillar as the big yellow construction equipment. And when I'm talking to our distributors or our customers, I like to explain it like this. A generator without cable and distribution is kind of like an excavator without a bucket. You really can't do much with it. And so oftentimes in the heat of the moment, someone will come in, they'll say, we need a generator, it needs to be a 20 kW, they'll hook it to the back of their truck, they'll get it to their facility and hit start, but the lights don't come on. They didn't get cables, or they didn't get the right cables, or they didn't get distribution equipment, which is basically the industrial equipment of a large power strip in order to plug computers or tools or other equipment into. And so you really need to think about the whole application as a system and how you're going to integrate it into your building and what you're actually planning to supply. The staffing requirements, I touched on that a little bit just a moment ago when we said who you normally expect to do this is likely not going to be available. So this can be mitigated with a minimal amount of cross-training at your organization. And there's also some other accessories that I think could help, and I'd like to highlight that in just a moment. In terms of bringing generator cables into your circuit breaker, one thing that I could recommend is that you could install some sort of a weatherhead or a cable access door in an outside wall of your facility that could then be closed when not in use. This way, you won't be required to route your cables through windows or doors or other areas that should be closed in non-working hours, either for safety concerns, for theft concerns, or even for weather concerns. That's something that often is not thought about, but it's really a simple thing that you can do that can make your life and your operation function much simpler. If you wanted to go a little bit above and beyond that, what I'm showing now is what we call a quick connect station. What this is it's an extension of your electrical distribution system that you would mount in a weather-protected enclosure outside of your building. And in the lower right, what you're seeing are cam lock connections, which are standard and 4-aught or 1-aught cables, which could, as close to plug and play as possible, connect the mobile generator into your facility. And what this will allow for is that in a lot of cases, this does not require a licensed electrician in order to make this connection, where connecting to actual bus bars with bare cables many times would. And so in this case, either your generator rental provider or your facility engineer would be able to make this connection and throw the switch, and you're back up and running in the least amount of time possible. So this is a great solution if you think you could ever find yourself in a situation where you need a temporary backup, even beyond your permanent standby generator. It's a very cost-effective option for the cost savings you would have and the time savings you would have when you consider trying to get everybody coordinated in a short period of time between your facility's technicians, a licensed electrical contractor if needed, and the generator rental provider. It just makes it a lot simpler and cuts out a middleman. Next thing I wanted to talk to you guys about is budgetary. What are you talking about cost-wise to rent an industrial diesel or natural gas generator in one of these situations? Now, I was advised over and over not to show budgetary numbers, but I think it's important. And I just need to caution you guys that if you're talking about in the Northeast where you've got high fuel costs and union labor, your price is going to be different than if it's in the Midwest. But perhaps in the Midwest, you might have longer transportation costs associated with your generators. And likewise, if you go to the West Coast, they may have more stringent emissions requirements, which requires more expensive, larger equipment, and even an additional grade of fuel quality beyond USLD that would be required to run there. So your cost profile can vary widely, but these are something that you can look at and have a general idea of what it's going to cost. These are more or less dollars per month. I'll give you a moment to digest those. 60 kW is running a small office building. 400 kW, is running a larger office building, a complex, a pumping station, and then a 2 megawatt is powering critical life safety at a hospital, refining applications, other major projects. And any of these nodes, if unavailable, can be paralleled together in order to meet your desired demand. There's a little bit of that. And then we talked about how dependent we as a society have become on electricity. That electricity, our computers don't run, our phones don't work, at least they don't recharge, and pipes freeze, food spoils, machines don't run, everything grinds to a halt. All of that has a cost, and this is a solution that can allow things to run as normal. But as much as we know we depend on power, temperature control is also something that is extremely critical. If it's either extremely hot or extremely cold, it's really hard to get people to come to work and be able to do their jobs in an effective manner. And so while you're looking at your power supply, if the event has also knocked out your boiled water or your air conditioning or whatever it may be, these same suppliers can supply you with solutions for those, and I'll show you those in just a moment. We talked about the different fuel options before, but I want to talk about it in context of mobile emergency response. Right now, from all providers, 90% of what you're going to have is diesel powered. Diesel power can cover the broadest range of applications because it has a very good startup profile in that it can handle major block loads. It's also going to be slightly smaller footprint and lighter weight than a gas engine. Of course, you will have the fuel, which compensates for that. It's also lower cost up front. From an emissions perspective, a gas overall would be a little bit better, but honestly, they're different emissions, and so we really can't say that 100%. There will be a much lower operating cost. So if you are planning to have an extended outage, not planning, but if you're going to have an extended outage, a gas generator is going to save you money over the long haul. And then serviceability is about the same. What we're showing here on this chart is just your rental rate on a gas genset will be higher than a diesel genset, but if you look at the overall total cost, dollars per kilowatt hour, running any significant hours at all, you'll start to save some serious money on a gas genset. So gas is becoming more and more a preferred source of supply in reliable circumstances. But what we see in the unplanned outage situations is that one of the first things that you see people do in the case of an earthquake, for instance, is they run out and they shut off their gas meters. And there's numerous calls from people all over who say they smell gas here, they smell gas there, and the city needs to go and shut off numerous source supplies until they can validate the integrity of the system and get that back on. So the people who are relying on permanently installed standby gas generators all of a sudden have them rendered useless by that gas supply being cut off. The other thing is that if everybody's gas generators kick on at the same time, there's not sufficient fuel supply in the pipelines oftentimes, and we get engine gensets choking out from time to time. So we need to think about that. The upside of the gas generator is that you do not have to deliver fuel. So if it's an environment where roads are impassable, trees are down, flooding, whatever it may be, and you can't get a diesel truck in to refuel your genset, but the pipeline is up and running, then you would have ongoing uninterrupted service at your facility. And that would be the advantage of going with a gas genset. So there's advantages and disadvantages of each, but right now, most people and the industry uses diesel solutions as the best alternative for unplanned outages. Here's those temperature control solutions, whether we're talking about heating. Superstorm Sandy hit in a very cold time of the year, and a lot of people could not function in their offices or anywhere without heat. And so the temporary supply of heat is something that you also should plan for. Likewise, air conditioning, dehumidification, or chilled or boiled water are other solutions that you need to understand. If your facility relies on those, the same considerations that you should have when working with a temporary solution provider would apply to these technologies, as do the others. So with that, I now want to switch gears to talk a little bit about a partnership we have with a organization called First Response Team of America. And we started working with them a few years back, I think 3 years ago, and they have really opened our eyes to some of the circumstances and some of the needs and the very first hour after a disaster. So I want to start with a short video here and let them introduce themselves to you, and then I'll make some comments after that. And you may need to turn the sound on your computer to hear the video. All right. And so just to, hopefully you guys all saw that video. We've been very proud to be partnered with First Response Team of America. And as we've gone through these 3 years with them, something we noticed was that when we talk to customers, typically they're calling us in order to get a solution, and they know more or less what they want or what they need in some cases. But what TAD has really opened our eyes up to were, in these very first hour, how many people have such need but don't know where to start and don't know what they need or have any idea of how much electrical demand they actually have. And so one thing we worked with him and his team on was basic generator sizing, how to understand what size genset to use. So the quickest and easiest and most accurate way to do this ahead of events is to take an ammeter reading of your electrical distribution boxes. And you want to take that reading when your company is in normal operating at peak load. You can also obtain your peak demand ratings from a utility bill. What happens if you don't do it ahead of time and someone just comes out to your site, unfamiliar with your business, trying to understand how much power you need, is they're going to look at the aggregate loads which are listed on your circuit breaker panels, your electrical distribution boxes themselves, and then take that, whatever that electrical capacity is available, they're going to size to that. But your electrical capacity is always going to be more than what you need. So what happens in these situations is you end up getting a larger generator than you actually need. The rental rate is more expensive. It's burning more fuel. It's not running at its most efficient point. And so we really recommend you to find either through taking actual ammeter readings or saving an old utility bill, so that in the case you need to know, somebody asks you what your load demand is, you'll be able to tell them. From there, you can do other more complex strategies of determining which of those loads actually is critical and which are not, and then you can open or close those circuit breakers depending on what you want to have running. The other thing that he really showed us was that how hard it is to actually get in and out of these places in the immediate aftermath. You know, we hear a lot about situations where he'll attempt to get approval, but as I mentioned before, the city permitting office may not be open. The police, fire, and rescue, they're busy and can't take calls and allow people in and out or access to work on things. There was one case of a hospital that was overloaded, but the roads were at an impasse and they couldn't get ambulances in and out. And so they actually created a temporary helipad and lit it up with their light towers and generators and allowed for people to be evacuated out and additional supplies in. There's all kinds of things like that that unless you're there, it's hard to think about. But they're things that First Response Team has has helped us with and has allowed us to hone our services even better. If you'd like to find out more about them, I've got their website there on the bottom. They are a nonprofit. I'm sure they would appreciate as much support or publicity as they can get, and I'm really proud to talk about their organization and what they do, and I'm proud to be partnered with them. So with that, I thank you guys for your time. Hopefully you found this information useful, or at least it brought up some questions or things to think about. And I will be sticking around to the end to answer any questions you might have. Thanks a lot.
Great. Thank you, Jason. This is Ezra Finken. I'm the Policy Director here at the Diesel Forum. That was a great run-through on important operational considerations for equipment use. I'd like to switch gears a bit and talk about how to get this equipment to critical infrastructure. Specifically, we thought we would dive in on policies and financial incentives to introduce the equipment as it relates to critical infrastructure. Typically, hospitals and shelters are required to have on-site power, but sometimes not other pieces of critical infrastructure. After Superstorm Sandy struck the Northeast almost 2 years ago to date, the extended outage severely impacted retail fuel locations. We saw a lot of that in the press as motorists and first responders couldn't get access to refuel. Quite a lot of states and other jurisdictions in the region quickly understood that motor fuel locations really need to be considered critical infrastructure in light of all those events, and should be deployed with emergency backup capabilities to help keep motorists on evacuation routes and allow first responders access to fuel to keep their equipment running. As a response to those events, New Jersey Governor Chris Christie, we understand, made available public funds to help retail motor fuel locations within a specified distance from highways and predetermined evacuation routes. Install necessary electrical equipment of the variety that Jason spoke about, some of those quick connect capabilities and some of the other really needed electrical infrastructure. To be able to connect to a mobile backup power unit or sometimes even install on-site power capabilities. The state also received federal funding to help ensure backup power capabilities at wholesale motor fuel locations in the state. As we read about in press reports after Hurricane Sandy, we understood that a lot of wholesale fuel distributors are located in New Jersey, and sometimes they didn't have backup power able to get that fuel out to retail locations. So there are federal grants that I understand the state has applied for to help with on-site power at those wholesale locations. Switching gears a little bit to New York. New York took a little bit different tack. After Superstorm Sandy, the New York legislature passed a bill that now requires retail motor fuel locations in critical areas, typically those within a radius of a major highway exit or a predetermined evacuation route, to install the necessary electrical equipment and components to provide backup power. Public funding was made available to help offset this cost, a lot like it was in New Jersey. Additionally, the New York State Energy Research Development Authority, known as NYSERDA, in conjunction with this program, operates sort of an offshoot to provide mobile generators to these locations at favorable and subsidized rates. There are other states that are, of course, prone to natural disasters. Florida, Louisiana come to mind. They typically bear the brunt during hurricane season. And they have also implemented similar policies in the not-too-distant past, providing similar financial incentives. After a particular costly hurricane season in 2005 and then 2006 with Hurricane and Rita almost back-to-back, Florida and Louisiana implemented these policies to basically keep motorists on evacuation routes. And also a bit more recently, just a year or so ago, the state of California also followed suit with the tax credit available to retail fuel locations that install on-site power, and I believe that there are further incentives for owners to install equipment that runs on alternative fuel sources. So that's just a quick rundown of some of the policies and legislation we've seen introduced to get some of the electrical backup power into the retail fuel location. At this point, I'd like to hand it over to Mike Jones with the Maryland Energy Administration, who's going to take a deeper dive into one of these really innovative and much-needed programs, the Fuel Up Maryland program that helps to provide funding and incentives to retail fuel locations to provide emergency backup power. So with that, I'm going to hand the ball over to you, Mike.
Thanks, Ezra. Again, as Ezra said, my name is Mike Jones. I work here at the Maryland Energy Administration. Well, first thing I'll note is it says Energy Resiliency Grant Program up here. If you've heard of something known as the Fuel Up Grant Program, this is the same program. We've offered a bit of a tweak when it comes to the name, but that is the same program. But first, I'd like to just offer a little bit of background about our agency. We are a state government agency. We're located in downtown Annapolis. Our mission is to promote affordable, reliable, clean energy, to lower energy bills, fuel the creation of green-collar jobs, address environmental climate impacts, and promote energy independence. We basically do that in a variety of different ways, whether it's offering policy support or grant or tax credit incentives to incentivize the deployment of energy efficiency technologies, renewable energies. We really do offer a wide variety of incentives and programs to help Maryland citizens go green. Including of which we do offer several transportation-related grant and tax credit programs to help reduce petroleum consumption. This Energy Resiliency Grant Program doesn't quite fall under the transportation umbrella in the traditional sense. It really falls more under emergency preparedness, which is a bit of a standalone area in terms of grant programs that we do offer, but we do think it's a pretty interesting program to offer. Nonetheless. So as several others have mentioned on this call, there have been a variety of different weather events, several disruptive weather events in the Maryland and general Mid-Atlantic region that have taken place over the past few years that really motivated the creation of the program, whether it was Sandy or Irene, the derecho, of course, or even the Snowmageddon that I'm sure we all remember a few winters back. So basically, all these weather events sort of set off a bit of an alarm bell with both members here at the agency and members in the state legislature that really raised the awareness that, it's important to have access to fuel for transportation and evacuation, and this became apparent, when these weather events took place. So as a result of that, the creation of this program was a reaction to all of those different events. And the Fuel Up Maryland grant program was created. In the broadest sense, it provides grant funding to offset the turnkey cost of purchasing and installing backup power generators and or pre-wiring. And I say that because most of our applicants in the program do decide to apply with the pretense that they will be installing some sort of generator. However, that's not necessarily a requirement. They can choose or elect to do pre-wiring for a generator, basically all the wiring, the transfer switches, everything but the generator. We've had applicants that have done that for a variety of different reasons, largely financial. Even with financial assistance, they felt it may have been in their best interest to just do the pre-wiring at this particular point. But most of our applicants have done backup power generators. By backup power generators, of course, that means fixed generators, and that was the large majority of applications that we received. But we also do allow applicants to seek reimbursement on portable generators, batteries, although we haven't really seen as many of those applications. And it's 70% up to a $25,000 maximum cap of the turnkey cost. And by turnkey cost, I mean it's exactly what it sounds like. We will offer reimbursement, that cost figure, on pretty much everything from start to finish, whether it's the engineering drawings, the permits, the transfer switch, the generator, all the electrical work, generator pad, labor, wiring, you name it. Our grant reimbursement would cover it. The only real expense that would not be eligible under the program is the cost of the fuel itself. So that's something that we would not reimburse, and as such, applicants would have to take that in mind when they're submitting paperwork, when they're applying to us. The 70% figure, that is the figure that was, that is what the program currently is at. That percentage has increased over time. It was initially 50%, then up to 60, then to 70, and that was done in order to boost attractiveness and awareness to the program. We didn't quite receive as many applications at the outset as we had expected to receive, and that may have just been the result of running a program for the first time, where you have to pretty much do everything for the first time and start from the ground up. But it's currently at 70% up to a $25,000 maximum cap. The first round launched a little over a year ago, on around August 15th of last year, and we've received a number of applications since then. As Ezra had mentioned, some other similar grant programs in other states have limited these applications to only come from service stations located in an emergency or an evacuation area. This program did start out following that similar line of thinking. Initially, only stations that were located within a half mile of an emergency evacuation route were eligible to apply. But however, for the same reason that we sort of boosted the maximum cap over time in order to boost applications to the program, for that same reason, we removed that provision from the program and instead opened up the program to all service stations in the state of Maryland. Really the only two eligibility requirements that existed for service stations in order to apply were that stations had to have fuel storage of at least 10,000 gallons and also had to have annual fuel sales of at least 75,000 gallons. But we believe and have found during the course of this program thus far that those are relatively pretty low thresholds. So we haven't come across too many stations that were interested in applying, and but were not able because they were too small. So pretty accepting thresholds. Basically, the way that we work our grant programs in the most general sense are that they come in a first-come, first-served basis. So essentially, when we receive an application and all the paperwork is there and everything matches up and there aren't any discrepancies and we have funding available, they are awarded a grant in the form of a grant agreement. So everything is on a first-come, first-served basis. This is not a competitive program. And in addition, all grant payments are made in arrears. No grant payments are made up front. And that will sort of delve into a little bit more on my next slide, where we just offer a very macro-level picture of the program process in terms of how we operate these applications. As I said, an applicant would submit the paperwork to the MEA. We would check the paperwork, and if everything checks out, we would mail a grant agreement to the applicant, at which point they would sign and send it back. And upon that date, the grant agreement would be what we consider to be executed, and we would notify the applicant, and that's when a project clock, so to speak, would begin. This says 180 days on here, but that's with some adjustments that we've considered making for the second round of the program. But for the first round of the program that just closed back in June, that was a 90-day clock, at which point they would have 90 days from that execution to submit reimbursement materials to MEA. That would essentially involve sending an invoice, proof of payment for the project, a cost breakdown, so we could get an idea of how much each category of the project would cost, and that would be it. So we would get that, and we have come to learn through the process that perhaps 90 days is a bit short. We've had some issues with applicants meeting that, so we have been and are exploring the idea of increasing that time window a bit, but that is how it worked with the first round. And then, if we got everything, we would then process the invoice, and payment would eventually make its way to the applicant in the form of a grant check. It would, as a state program, it has to go through a few channels first. It does have to go through our state finance office, the comptroller office, but the applicant would receive a grant if everything was there and accounted for. As I mentioned, the first round of the program closed back on June 1st, which was the point at which we stopped receiving new applications. And thus far, we ended up with about 31 awards that were executed, totaling approximately $680,000 in grant funds. You sort of have to put a bit of an asterisk next to both of those figures. An asterisk has to go next to that number because we have had applications, or applicants rather, drop out along the way for financial reasons. Some smaller stations may not feel that even with the financial assistance that they could comply with the agreements in terms and stipulations of the program, and will drop out. And this figure, $680,000, is based off the awards that were given based off, the cost estimates that had initially been received, but the actual amount that is paid out will likely differ a bit from that figure, as we've been seeing that, from the time of application to the time that, the generator's put in the ground and paid for, these cost estimates can change quite a bit, which would obviously have an effect on the grant amount that we ultimately pay out. But nonetheless, it's been a positive experience with the first round of the program. We're currently working through many stations that are wrapping up right now. As we speak, a large majority of the applications that we received in terms of ones that were executed were not executed until the later months of the program. So with that 90-day clock and some extensions that we've had to give, a lot of those applicants are wrapping up and have been wrapping up completion on their stations over the past month or so, and will likely continue to do so for the next month or two. But as round one is closed, we have been working to open a second round of the program, which will be slightly different from the first round, which necessitated the name change from Fuel Up to Energy Resiliency Grant Program. It's just been really a change in semantics, but part of the reason for that change is that with this second round of the program, we will be opening the program up to firehouses. And as such, the intention for those particular firehouses won't be as much for you know, allowing for fuel access, you know, for people's vehicles, but really to just offer more of an emergency preparedness benefit for those local communities so that they can stay open and serve the local populations as needed during those emergency events. Unfortunately, can't really go into too many details as to just how that second round of the program will change, as we're currently still working internally to get all of our ducks in a row to get that ready to launch. But we do hope to launch the program soon. We have received a lot of interest from various entities, whether it's service station organizations or electrical contractors that had some experience working with clients in the first round of the program, and governmental organizations that work with local communities. Basically just had a lot more interest in this program, so a lot of people are waiting on our word to get the program up and running, so we will be excited to do that when we are in fact ready to launch. And of course, when that time does come, I would be more than happy to share that alert with everyone on this call, and I'm sure I can touch base with Kristen to make sure that information gets out. But nevertheless, what I can say is that we have been working to make some slight programmatic adjustments to basically streamline the overall process in general, to reduce the applicant burden, in steps that we hope will boost applications, get more generators and more stations and more firehouses, and create a larger network of prepared locations that'll be ready to keep the lights running and the power running and fuel pumps operating, you know, should we have any more severe weather events. The last thing that I think I'll mention that I don't think I went over that I'll double back on is I believe someone on a previous presentation here on this webinar had mentioned that there were some requirements that had to be met for diesel generators. And as I had mentioned earlier, we do accept pretty much all types of generators, and that includes all different fuel types. But with the diesel generators, those do have to meet EPA Tier 2 emission standards. But we do feel that, and from what we've gathered with our experience with the first round, is that a very large majority, if not basically all, of the generators that are commercially being sold to these service stations do in fact meet that criteria. But just something to keep in mind as well that I wanted to throw in there. But with that, is I try to do my best to keep it sweet, short, and to the point. But that is pretty much all I have. I'd be happy to go into more detail on the mechanisms or inner workings of the program. If anyone has questions, my contact information is available there. By all means, feel free to reach out and let me know if you have any questions. All right, thank you.
Great, thank you very much, Mike. Appreciate that that overview of the Maryland program, and it sounds like it's Phase 1 has been a great success, and Phase 2 is gearing up for more of the same. We appreciate everyone hanging with us. We're well beyond the allotted time for today's session, and looking at the Q&A here, I don't see any immediate questions that are available. I think a number of folks have noted that that they're familiar with hydrogen fuel cell technologies that have been deployed during previous outages, and we certainly acknowledge the availability of other energy sources and supplies there. And unfortunately, I didn't have time to highlight all the different ones for today's session. If there are any questions, you can send them along to me in the chat feature, and we'll be happy to answer those. Otherwise, we're going to go ahead and move forward to our concluding remarks here. And let's see, this webinar and all the presentations you can get on our website in about the next 24 hours or so. at this URL. If you have any difficulties there, please email us. We'll be happy to make sure that you get those. But hopefully today's session was a good overview of the different choices available for backup power generation and the different advantages and disadvantages of each fuel and technology. And we look forward to continuing a dialogue with everyone about the role of clean diesel technology and helping to keep the lights on. Just a quick plug for a upcoming demand response webinar that will get more into details of using diesel generators to help shore up the electrical grid during times of heavy load or anticipated blackouts or brownouts. And you will be getting an invitation to that for having participated in this webinar. And let's see, finally, I guess the last announcement is, Kristen, I will hand it off to you to kind of close things out from the webinar perspective.
Thank you, Alan. And thank you, everyone, for attending. Just a reminder that this recorded webinar, as well as the presentations, will be loaded on the Diesel Technology website within the next 24 hours, so you can access all of that there. When you close out of this webinar today, you'll be taken to a brief survey about your participation, so we encourage you to fill that out. It gives us some guidance on today's presentation, as well as some upcoming webinars that we have planned for later in the year. Thanks a lot for joining us. Have a good afternoon.